zero, and negative exponents. In this video, we'll define expressions with zero and negative exponents, and then we'll use the definitions to rewrite expressions with negative exponents to equivalent expressions with positive exponents. In the previous video, the definition of exponent, x to the power n, is n copies of x multiplied, and needs to be a counting number to count the copies of x. We used the definition to derive some properties, and we can use the properties to simplify exponential expressions. Now we're going to do something really mathematical and use the property that we derived from the original definition to extend the definition to include negative exponents and zero as an exponent. And we're going to do it like this. If I have a expression x to the third over x to the fifth, and I'd like to simplify it, I'm going to have 3 copies of x on the top, 5 copies of x on the bottom. When I cancel, remember canceling leaves a 1 behind, the expression is 1 over x squared. But if I simplify the same expression using the division rule, I have x to the power 3 minus 5. Which is x to the negative 2 power. So what if I define this negative 2 power to be the result that I get when I write it out? We can define x to the negative n power as 1 over x to the n power. Let's do something similar to define 0 as an exponent. If I have x to the third divided by x to the third, well, anything divided by itself is 1. But using the division rule, x to the third divided by x to the third simplifies to x to the 3 minus 3, which is x to the 0 power. So I'm going to define x to the 0 power as being equal to 1. We're going to use these definitions to simplify some expressions and rewrite them without negative exponents. The first one is 3 times a to the negative third. The number 3 is multiplied by the expression a to the negative third, so we rewrite that as 1 over a to the third. Now, when I'm multiplying a whole number times a fraction, I can put the whole number over 1. And so I end up with 3 on the top, a third on the bottom, 3 over a to the third power. The next expression, a to the third times a to the negative fifth, means a to the third times 1 over a to the fifth. But instead of doing it that way, I'd like to do it with the multiplication rule. So that's going to be equal to a to the 3 plus negative 5. Well, that's a to the negative 2, and that is 1 over a squared, according to our definition. You would get the same answer either way you worked it. The last expression is kind of tricky. I'm going to show you 2 different ways to simplify it. The first way would be to think of this 1 as being an a to the 0 power. So if I rewrite it like that, a to the 0 over a to the negative 2, and then I use the division property, that's going to be a to the 0 minus negative 2. Well, when you subtract a negative, you get a positive, And so I end up with a squared for this expression. Now I could also write it as a complex fraction, 1 over 1 over a squared, and simplify by multiplying the top and bottom of the complex fraction by the common denominator a squared. That would give me a squared on the top and a squared times 1 over a squared on the bottom, which is 1. And so I also get a squared simplifying that way. So we've expanded our definition of exponents to include 0 and negative exponents. X to the 0 power is 1, so long as x does not equal 0. And x to the negative n power is 1 over x to the n power, again, as long as x does not equal 0. This negative exponent makes the expression the reciprocal of what it would be with the positive exponent. And we can also write 1 over x to the negative n is equal to x to the positive n.